So Nike thinks has found a way to make running shoes last longer than a current average of 750. So that kind of like they think they're going to do something with the current average of 750. So I'm betting that will probably be our null or the status quo. Let's keep going. A sample size of 35. So we have n equals 35. Are selected toward the new design, and the shoes last an average of 815 miles. Now that would be the average of our sample. X bar equals 815. Assume that the population standard deviation is 25 miles. Notice this is our population standard deviation. So sigma equals 25. Now anytime you have a population standard deviation, you know that you're going to want a z. You're going to use z instead of t. Let's see, conduct a test to see if the average distance for the new design will last is greater than 750 miles. So we want to know, is our population mean greater than 750? So that's our question of interest. So we're going to use a z-test for the mean, a one sample z-test for the mean, because we knew that population standard deviation. Our condition that we have to check is we need to have n at least 30 or normal data. In our case, n is 35, so we're good there. Now you need a level of significance. I will just choose alpha equals 0.05 because if I don't have anything else, I will just always choose alpha equals 0.05. Now for your hypotheses. The null hypothesis is going to be that our population mean is equal to 750. And our alternative will then be that our population mean is greater than 750 because that's what we wanted to know. Now for your test statistic. Our test statistic z is equal to x bar minus our hypothesized mean over our population standard deviation over the square root of n. So x bar is 815 minus what's in your null, so 750, over your standard deviation of 25 over the square root of 35. And this should give me 15.38. Now for your p-value, you're going to draw a normal curve here. I'm going to be looking for z equals 15.38. Because this is a greater than, I'm going to shade to the right. So I need to have some kind of normal calculator. Oops, no, right class. Okay, I was going to say I had the wrong class. I don't have the TI emulator anymore. My trial was done, so I'm just going to pick a website to do this from. But you want to use your, here, let's write it down first. For the p-value, you want to use the normal CDF function. You're going to do a mean of 0 and a standard deviation of 1. Because anytime you're working with z, it always has a mean of 0 and standard deviation of 1. And we'll do our lower limit of 15.38 and our upper of like 1 million or billion or whatever you want to type in. So coming here to try this. So my mean is 0, standard deviation is 1, and I want it to be between, oops. Sorry, I forgot I don't have a keyboard at the moment, so we'll just kind of skip that. But you put into your calculator as a normal CDF, lower is 15.38, upper is 1 million, and so your p-value, or that area, is 1.14 times 10 to the negative 53. Now, basically, that's about 0, and most of your calculators are just going to tell you 0 because it was so small. So that is going to be a small p-value. And so anytime I have a small p-value, I will reject my null. So in our case, we have evidence that the population mean is greater than 750 miles. And last step is to interpret the p-value. So the p-value, remember, it can't be any of the simple interpretations. It has one interpretation. You can change the order of it, but it has to have these three basic parts. The interpretation of the p-value tells you if the null is true, then the p-value is a chance of getting your sample mean. Any way you want to reorder that, it has to have those things. If the null is true, it's the chance of getting your sample mean, or something more extreme. If the null is true. So in our case, if the null is true, that means if our mean really is 750. So if our population mean really is 750, there is a 1.14 times 10 to the negative 53, or basically 0, chance of getting a sample mean of what was our sample mean? 815 or more. Which is so small, there's like no chance that would have happened if our population mean really was 750.